Friends, welcome to my channel. Today I shall solve some problems on Fourier series. In fact, I will show you one problem here. So if we have one function fx, the Fourier series of the function fx in the interval say alpha. In this interval, this fx function can be expressed as, this is the Euler's formula which I am writing right now. N is equal to 1 to infinity an cos nx plus n equal to 1 to infinity bn sin nx. Okay, this is the expression, and a0 is equal to 1 by pi alpha plus 2 pi fx dx, and an would be equal to 1 by pi alpha plus 2 pi fx cos of nx dx, and bn would be equal to 1 by pi alpha plus 2 pi fx sin of nx dx. Okay, the values of a0, an and bn are known as Euler's formulae. So let's go to one problem. Here we have the problem: obtain the Fourier series for fx equal to e to the power minus x in the interval of interval of 0 x 2 pi. So here we have fx equal to e to the power minus x. So let's write here. So let e to the power minus x is equal to a0 by 2 plus of n equal to 1 to infinity an cos of nx plus bn sin of nx. Let's give it equation number 1. Now what we can do, that a0 is equal to 1 by pi, and we have the lower limit 0 and upper limit is 2 pi. So fx dx, that is e to the power minus x dx. We have to perform the integration, that would produce say minus pi of 1 by pi of e to the power minus x 0 to 2 pi, 0 to 2 pi. Okay, so it is minus that would be producing 1 minus e to the power minus 2 pi. So let's give it equation number 2. Now I shall find an here. So we know that an should be equal to 0 to 2 pi. Here 1 by pi will be there, e to the power minus x of cos of nx dx, right? So we have to calculate this integral. Here we are putting equation number 3 here. Now let I is equal to say e to the power minus x cos of nx dx. I am omitting the limits here, and to solve this integration I am letting that I is equal to this. So let's remember another thing, that the integration by parts, which will give you u v dx minus of u dash, that is first derivative of u, and v dx, right? And another thing you should be remembered, that is liet. This is log, indices, algebra, trigonometry and exponential. So I can write, so cos of nx will come out of the integration, and I can solve the integration e to the power minus s. This is the thing. And then let's give this negative sign, and then integration of n of here will be one minus sign. Let me write it properly. Let's give this sign, and first derivative of cos nx, that will produce sine of nx into minus n. Okay, and again the integration will produce minus of e to the power minus x dx. So signs are really important here. If I mistake, then later we will face some problem, real problem. So we are getting ultimately negative sign. So I am getting sine of n sine nx to the power minus x dx. Let's do it. So again I will get this out of this integration, and e to the power minus x integration will produce another minus e to the power x. So it should be this. And the second part, let's write, let's put one negative sign here first, and then first derivative of sine nx, and n is there, so I am writing cos of nx times n square, and to the power yeah, this integration is okay. So we write cos of nx to the power minus x plus n times sine nx e to the power minus x minus n square times I, or n square plus 1 times I is equal to e to the power minus x minus of cos nx plus sine nx, right? So I is equal to e to the power minus x by n square plus 1 minus cos nx plus sine of nx. Let's give it equation number 3a. Using equation 3 and 3a, we get so an is equal to 1 by pi of e to the power minus x n square plus 1 minus cos of nx plus sine of nx, and the limit will be 0 to 2 pi, 0 to 2 pi. So that would produce 1 by pi e to the power minus 2 pi, and this will give you minus of 1, and this will give you 0, and this thing, and that would give you again e to the power 0, that is 1, and and minus that 1 square plus 1. So ultimately I am getting 1 by pi n square plus 1 and 1 minus e to the power minus 2 pi. Let's give it 3b, and if we get some value, it will start from a1, as the summation we have chosen n is equal to 1 to infinity, and so a1, let's first find a1, and that would be equal to 1 minus e to the power minus 2 pi 3 let's be 2 pi, and we can similarly find a2, that would be 1 minus e to the power minus 2 pi, that would be 5 pi, and a3 also can be found, that is 1 minus e to the power 2 pi, and that will be 10 pi, and so on. Now let's find bn. We know that bn is equal to 0 to 2 pi fx is equal e to the power minus x, and that would be equal to sine of nx dx. Then we have to solve this integration. For that, let's put equation number 4 here. Now let j is equal to e to the power minus x of sine nx dx. Okay, so again that uv technique, that is uv dx minus of u dash v dx, and let so sin x will come out, and this will give you e to the power minus x. Now negative sign is there. First derivative of sin nx, that would produce this, and integration of this will produce e to the power minus x dx, equal to minus of sin nx e to the power minus x again we have like this, so this time is n cos nx e to the power minus x will be there, and then put the negative sign again, and first derivative will produce minus n square of sin nx, and that to the power minus x, dx. So minus of sin of nx e to the power minus x minus I have to check it whether I am right or wrong again, because the integration sign may give some trouble if I am mistaking something. So here we will have plus again minus n square of j. You can see that is n square plus 1 times j is equal to minus of sine of nx, let's write it to the power minus x here, plus cos of nx if I am not wrong, that is j is equal to minus e to the power minus x plus n square plus 1 sine of nx plus cos of nx. 1 minute. There is n cos nx. I have mistaken that n should be there, right? So let's give it 4a. Using equation 4 and 4a, we obtain bn is equal to 1 by pi of there will be n square plus 1, and let write it like this: sine of nx minus n cos of nx, and that is 0 to 2 pi by pi e to the power minus 2 pi. This will produce 0 and this will produce minus n. So minus n, again that minus sign, minus of e to the power minus x, and e to the power 0 1, and this will be cos 0, that is 1. So this will give you n square plus 1. So if I write it, that is n pi n square plus 1 1 minus e to the power minus 2 pi for b. Hence b1 is equal to 1 minus e to the power minus 2 pi by 2 pi. b2 is equal to twice of 1 minus e to the power minus 2 pi, and that would be 5 pi. And b3 would be 3 of 1 minus e to the power minus 2 pi, and that would be 10 pi, and so on. So if we write the series ultimately, so hence e to the power minus x is equal to a0. A0 was, I think, 1 minus e to the power minus 2 pi by pi. You can check it. A0 was that, and an's value was like this. So let's write it: plus of a0 by 2 is written, and now I should write that n cos nx, that is half of cos nx, that is cos x, plus 1 by 5, it is taken common, 1 by 5 cos of 2x, plus I remember 1 by 10 cos of 3x, plus dots and so on. And now write that sign terms. So bn is equal to b1 is equal to, so half of sin x, then 2 by 5 sin 2x, then 3 by 10 sin 3x, and so on. So this is the Fourier expansion for e to the power minus x in the interval of 0 to 2 pi. So hope you have understood the problem. I have solved this problem. I have obtained the Fourier series of e to the power minus x in 0 to 2 pi range, and you can do it yourself also. Be cautious while you are solving the integration. thanks for watching my video and stay tuned with my channel. Thanks a lot.